Hey everyone, this is Armand, the creator of ChartLogic. In this lesson, we're going to learn all about sets and how to use the set condition. This is another leap in expressiveness with modeling strategies in ChartLogic, but it comes with a little more complexity. If you're ready to get logical, then let's get started. Here's where we are in the ChartLogic course. We're starting to get into some more advanced topics. If you're watching this video, then you should already be familiar with the concepts of conditions and how they're evaluated, the data they return, and variables. If not, you probably want to go back to the previous lessons first. Let's start with the basic concept of a set. A set condition is very similar to a logic set in that it can contain conditions of any type, but it does not contain actions. And unlike a logic set, a set condition can set a variable. What gets set in this variable depends upon what kind of a set it is, so we'll cover that in each of the particular cases. With most conditions, you don't create the name yourself. The name is automatically set based on the condition's configuration. When you adjust some values in the set condition, it will update the name, like if you change the conjunction or some of the options in the iterators, which we'll cover later. But you can also manually change the name to whatever you want, in case you'd like something more descriptive in the name. Just be aware that if you change the settings again after you've renamed it, then your name will get overwritten by the default name. The conditions in the set are evaluated in sequence. Just like with a logic set, you can click the sequence number in the first column to move that row up in the list. As you edit conditions in the list, they get their row highlighted, just like in the logic set, to help you keep track of where you are. Something you don't see in the set condition dialog is the cycle or the expiry. Like a logic set, a set condition will give its conditions an opportunity to be evaluated on every tick. It is the cycle and expiry of the conditions contained within the set that matter, not the set condition itself. When a set condition is evaluated, it receives the input variable from the previous condition, just like any other condition. It passes that value to the first condition in the set. The output value of the set condition depends upon what kind of set it is, which we'll cover next. Sets can be nested. One set can contain other sets, and these can, in turn, also contain other sets, and so on. There's no official limit to the number of times that you can nest sets. You can build structures of arbitrary complexity with these expressions. Depending upon the type of sets you're nesting, it may start to have an impact on performance, though. For instance, if you nest several large for loops, it's going to add up. The AND set joins conditions together with an AND conjunction. You can toggle the conjunction by clicking the button here, which currently says AND. Here is an example of an AND set. In this case, it really does behave like a logic set. The first condition is given the input variable that was passed to the set condition. It is evaluated, and if it evaluates as true, either because it is not expired or because it was a new cycle and it was able to calculate its data, then it returns a value, which is passed to the next condition in the sequence as the input variable. If all conditions in the set are evaluated as true, then the last condition in the set has its value returned from the set condition as its value. Also, if the set condition has a named variable, then it is the value from the last condition in the set that is getting saved to the variable. Here is an OR set. Here I'm saying that either we don't have a variable called YH signal set in the variable space, or the close of the previous candle is higher than the value set in this variable. This is slightly different than just using the candle condition by itself, because this version will return true if the YH signal variable is not set, which the candle condition by itself would not do. An OR set will evaluate as true if any condition in the set evaluates as true, and it will return the value of the last condition to evaluate as true as its value. This means that every condition will always have an opportunity to be evaluated, even if previous conditions in the sequence evaluated as false. Usually in logic sets and in an AND set, when a condition evaluates as false, it means that no conditions after that are evaluated. We often use this in our strategies to control when things happen. When all of the conditions are true, then all of the actions are run. But note that this is not the case in an OR set. You have to keep in mind that all conditions in the OR set will be evaluated on every tick, subject to their cycle and expiry, and any actions they perform will still take effect. Mainly this means that if they themselves are setting variables, then these variables will get set as usual, even if previous conditions in the set evaluated as false. A not set will return true if any condition in the set is evaluated as false. When a condition fails evaluation, then processing stops there, and that value is returned. Usually when a condition evaluates as false, it returns no value. So a not set would typically not return a value because it's returning true when a condition fails. However, there is one case where a condition returns a value when it evaluates as false. That's a price condition. The price condition is testing whether price has passed some target value. Once it's reached that target value, then it's done its job. It's more interesting to track a value from the price condition while it's still waiting for price to reach the target. So even though it's returning false when it hasn't reached its target yet, it's setting the named variable and returning the value of the target price when it's false. You can see this value in the strategy viewer as well. What this means for the not set is that the not condition's result will contain a value when a price condition fails, because that's when a price condition is returning a value. An iterator is a feature of programming languages that lets you step over a range of values and perform some activity for each item. Chart logic has a similar feature, but it has some unique characteristics. It most closely resembles a for loop, and for this reason, this is called a for set. There are three pieces of information for a loop: the starting value, the step value, and the count value. These values are composed into a looping expression that looks something like this for loop. The loop supports both directions, depending upon whether the step variable is positive or negative. This way you can loop up from 0 or down from some known value. These values can be set explicitly, or you can obtain the values from named variables, just like with any other type of condition. This is how this works. You add conditions to the for set. The set acts like an and set. We're looking for all of the conditions to be true in a loop. Cycle is not reset during each pass through the loop. If this is the condition's cycle, then the condition will recalculate on every pass through the loop. If it's not the condition's cycle, then whether it evaluates as true depends upon its expiry, as usual. For each pass through the loop, the for set will take the value of the iterator and set it in the variable space. The conditions in the for set can access the iterator variable just like any other variable. For example, if you're using this iterator variable to test candles with a value from 0 to 100, then there will be a variable in the variable space with the name I, and the conditions in the set will be called 100 times, and on each call, they can access each successive value of I. You could use this variable, for example, in a candle condition as the candle shift to test each candle's value within a range. When the set is finished with the loop, it removes the iterator variable from the variable space. It is only valid for the duration of the loop. As is typical with a set, the value of the set comes from the last condition in the set, but only when all of the conditions are true. For a set, this is the same, except that this will apply to the last pass through the loop where all of the conditions evaluated as true. There are three different types of for sets: the for each, the for while, and for until. You can adjust the iterator type by clicking this button to toggle through the options. The for each loop will execute all loops, regardless of whether any conditions are evaluating as true or false. It will only return a value from the last loop where all conditions evaluated as true, if that happened. The for while loop will continue as long as all conditions in the loop are evaluating as true. Once any condition in the loop evaluates as false, then the entire loop exits, and it returns the value from the last condition in the loop for the last pass where all the conditions were true. The for until loop will continue as long as any conditions in the loop are evaluating as false. Once all of the conditions in the loop evaluate as true, then the entire loop exits, returning the value from the last condition in the loop where all of the conditions evaluated as true. Okay, I know that that's a little bit hard to follow, so let's look at some examples. Let's consider a loop with 3 passes and compare each of the set types, the for each, for while, and for until. In the for each loop, all conditions will get evaluated for all passes through the loop, regardless of whether they evaluate as true or false. In this case, the final condition of the second pass will get returned as the set's value because it's the last condition in the last loop where all conditions were true. But pass 3 through the loop still gets called. A for each set will always evaluate as true, even if none of the passes through the loop had all of the conditions evaluate as true, but it only returns a value when it had a pass where all conditions evaluated as is true. In the while loop, we evaluate conditions as long as they are true, and then we stop when we encounter a condition that fails evaluation. In this case, processing stops when condition 2 is evaluated as false during the second pass. No other conditions are evaluated after that. In this example, the set is returning the value of condition 3 as returned by the first loop as its value, because that's the last loop where all conditions evaluated as true. Pass 2 through the loop did not finish, and pass 3 through the loop never got called at all. The for while loop returns true if it had any pass through the loop complete with all conditions evaluating as true when it's returning a value. If no pass had all conditions evaluate as true, that means that it didn't even finish a single pass. It's returning no value, and the set evaluates as false. And then finally, in the for until case, as long as a loop has a condition that is evaluating as false, it will continue running passes through the loop. In this case, the third pass had all conditions evaluate as true, and so at the end of this pass, the set returns as true with the value from the last condition of that last pass. The set will evaluate as true if the last loop had all conditions evaluate as true, where it's returning its value from. If no loops had all conditions evaluate as true, then the for until set evaluates as false. Let's take a look at some actual live examples, because I know that these concepts are a little confusing and looking at them on slides can be really abstract. So let's look at some real stuff. So what I have here, I have examples of each of the 3 different kinds of for sets so that we can see examples of how these are going to be different. Let's look at the first one first. So this is the for each mode. And what I'm doing here is I'm setting a variable called test_var to a value of 1, and then I'm running a loop. This loop says we're going to run from an iterator of name I, from starting value of 0, we're going to step in increments of 1, and we're going to run 100 times. And then I'm doing a number of things in this set condition during this loop. The first is a test to say that this test variable is set. The second one is a test that says the test variable is not set. And the reason I'm doing these 2 tests together is to demonstrate that both can't be true at the same time. Either test_var is set or it's not set. So one of these is going to pass and one of these is going to fail. So there's always going to be a case in this loop where something is failing. And yet it's still going to go through all of the loops because it is an each set and it doesn't care if there's a failure in the set. It's just it's going to do what it does every single time. And then the last thing that it does is it takes that test variable and it increments it by 1. So every time through, it's going to add 1, the number 1 to test_var. So we're going to start at 1, and then 100 times we're going to add. So let's see. And then when this runs, the action is we're just going to draw a line on the chart, and then we're going to put some text on that line so that we can see for each the test_var. So we're going to print out the value in a way that we can see it on the chart. So what do you think we're going to see when this condition is evaluated, when the for each set is evaluated? So we're going to see a line, we're going to see a number, but the question is, what is the number that we're going to see? Turn that on. We're going to see 101. So let's talk about why that was 101. So we have this for set. We start with a value of 1, and then we run 100 times. And let's bring this over so we can see a little more clearly. And the last time through the loop, the 100th time through the loop, we had a value of 100. And then the last thing we did was we added 1 to it. So that became, after 100 times, it became 101. We started with a value of 0. We started with a value of 1. That test_var had a value of 1. And then we ran 100 times, and 100 times we added 1 to it. So 100 plus 1 is 101. Let's take a look at activate, or enable, I guess, the while loop. And so in the while loop, it's exactly the same thing, except I've just changed the loop type from the for each to a for while. Now in this case, I have a test here that says test_var is less than 50. So a while loop will continue to run for as long as all of the conditions in the loop are true. So this will be true up until the point at which test var reaches a value above 50, and then it will no longer be true, and then it will stop. And then as long as the first condition is true, then the second condition will run, and we'll add 1 to that test var. So same question, what value do you expect to see displayed in the chart? 50. So why did we get 50 here? So let's take a look at this for loop again. All right, so we started with a value of 1, and we started looping through. We were going to loop 100 times, but as soon as test var got to a value that was greater than 50, it stopped. And so when it evaluated this condition, test var is less than 50, when test var had a value of 51, it failed, and then it returned. But the value that it returns is the last value from the last loop where everybody evaluated is true. And so when the last time that every condition evaluated is true, this was less than 50, which meant it was 49. And then this next condition evaluated, and that made it 50. And then it started a new loop. And then when it was 50, it was no longer true, and then it exited. So it exited with a value of 50. Okay, and then let's take a look at this last one. Let's enable the until loop. We'll look at this iterator. Okay, so this is an until. And now we have a test that says the variable is greater than 50. And so an until will continue to execute loops as long as something in the loop is failing. And so every time through the loop, this test var is going to fail until it gets to the point where this value is to where test var is greater than 50. And then it's going to exit. Okay, so same question. And this one is a little harder. What's the number that we're going to see in the window when this runs? It's showing 52. And I bet everybody looked at that and said, oh, it's going to be 51 because it's going to be 50. And then as soon as it's above 50, then it's going to fail. And then, we're at 51. So why did we get 52? Why did we get all the way to 52? So let's see if we can, let's bring this condition up again. Okay, so the until says we're going to run as long as everybody is failing, and then we're going to do our thing. And so let's start with test var is 49. 49 is not greater than 50, so it's going to fail. That's what we're looking for in the until, for it to fail. So if when test var is 49, this fails, and we go to the next one, and now test var becomes 50. Now test var is 50. 50 is not greater than 50, so it fails. And we go to the next line, and so now test var is incremented, and it has a value of 51. Now we run through another loop. Test var is 51. 51 is greater than 50. That's true. We go to the next one. 51 plus 1 is 52. And now we're in a loop where every condition evaluated is true, and so we return the value at the end of this loop where test var equaled 52, and that becomes the value of the set condition, which you can see in the strategy viewer here. The value of this set is 52 because it passed. So it makes sense, but I understand it's confusing. It's just something you have to get used to. All right, I have one other strategy loaded here that it might be interesting to take a look at, and these are just some tests of the not condition, just to help clarify, just to make sure that we understand. So I have some trades running on this symbol. I think there are 5 trades that are currently running. So I have a not condition here where I'm testing that we have fewer than 2 trades. So I'm using a trade condition to get the count, the number of open trades, and I have a test that says that number is less than 2. And the number is actually 5. So this variable here is going to be false. But we are in a not test. We're in a not set. So because this is false, it's going to return as true. So let's take a look at that. Let's enable that, and let's turn these things off. So we're expecting this to be true, for the not set to return as true. And so this logic set, not test, should pass, and it did pass. And it passed because this failed. So this failed, so this was false, but because this is a not set, because it was false, it returned as true. Okay? And then let's take a look at the next one. Oh, I already had it activated. We could have just looked at it right there. All right, we'll turn that off, save it, and run it again, and take a look at it. And now this is the one that should fail. And we can look at what this test is, and I'm saying that the input needs to be greater than 2, and that's the test. So with the number of trades, the trade count is greater than 2, so this is actually true, input greater than 2, because the number is actually 5. But because it was true, the not set returned as false. So this not test, we expected that to fail. And then the last thing in this strategy to show is this weird behavior of a not condition with a price condition when it fails. And that was an unusual thing that I wanted to make sure that it was clear. So let's turn those on and run it and take a look at those. So in this first logic set, I just have a price condition. And this price condition is failing because it has not yet exceeded that price. And it's a little hard because I have all of the colors turned off on this chart. But this condition is failing. I'm waiting for price to get below. I'm waiting for price. I don't know where price is. I'm waiting for price to get above this value, and price is not above this value yet, so this condition is failing. But because it's a price condition, when it's failing, it's returning a value. And so we get the value that's being returned, and then that I'm showing that value on the price line. So it's a little bit weird that a price condition is returning a value when it fails, but that's what's going on there. And then let's do this one at a time instead of everybody together. Because I don't know who's writing the text. I don't want everybody writing text at the same time. Okay, so now we have a price condition. This is the same thing, except it is now a part of a not set. So again, I have this price condition that's returning false. You can see that in the strategy viewer. This price condition failed, it's returning false. But I am part of a not set, which means the not set is returning true because the not set has a condition in it that returned false. And the value of this set has been set to the value returned by the price condition because the price condition returns its value when it's false. See what's going on there? So the not set returns true because the price condition returned false and the price condition returned a value, and the not set gets that value. Okay, and then finally, there's one more example in here, and let's take a look at this guy, see what he's doing. So we have a price condition which I'm expecting to return false, and in this case, I know what we're doing here. We're setting it as a variable. So we're putting a variable in the variable space when the price condition is evaluating as false. So let's run it and we'll take a look. So price condition variable, and now I have a variable set in the variable space, and the variable has that value even though the price condition is failing, because that's what it does. Hopefully all of that is much more clear now. Thank you for watching. Chart Logic is available in the MQL5 market. If you liked this video, please give it a like to let me know that this is the kind of content you're interested in. And if you're so inclined, you can subscribe and click the notification icon to be notified when I post new videos. Leave a comment below to let me know if I made any mistakes or if there are any features you would like to see in future versions.